We are going to make a regression equation for the following example. Our values for x are 1, 2, 2, 3, 3, and 4. And the found values for y are 2, 3, 5, 4, 5, and 7. And now we can display these found values in a scatter plot with the x values obviously on the x-axis and the y values on the y-axis. And now we can enter the values. With an x of 1, there was a y of 2, and so on. And after entering the values in the scatter plot, you have an idea of what your data looks like. But now we're also going to want to add a regression line. To add a regression line, we also need a regression equation. And why do we want to add a regression line? Well, we want to see if we can use the values of x to predict the values of y. Because then you don't have to measure y anymore in the future, and instead you can give a good estimation of the value of y based on a given value of x. So for this, we will need a regression equation. And a regression equation looks like this. The found value of y equals b0 plus b1 multiplied by xi. That means a constant, b0, plus b1, which is the slope, multiplied by the found value of x for a given individual, plus the error for this individual. And you can also say that the found value of y equals the predicted value of y, which is the model plus the error. The error is therefore the difference between the found value of y for the individual and the predicted value of y for the individual. Now, to fill in this formula, we're going to need b1 and b0. And we're going to start with b1, which we calculate like this. The correlation between x and y multiplied by the standard deviation of y divided by the standard deviation of x. And we calculate b0 with the following formula, namely the mean of y minus b1, which we have calculated in the formula above, multiplied by the mean of x. And we then need a number of values, namely the means of x and y, the standard deviations, and the correlation. So the mean of x equals 2.5, the standard deviation of x equals 1.049, the mean of y equals 4.33, the standard deviation of y equals 1.751, and the correlation between x and y is equal to 0.8711. Now we're going to start calculating b1. b1 is the correlation between x and y, which is 0.8711, then multiplied by the standard deviation of y, which is 1.751, and then divided by the standard deviation of x, 1.049. And that's going to be 0.8711 multiplied by 1.669, so b1 is going to equal 1.454. Let's put this aside for now. And now we're going to continue with b0. b0 is the mean of y, which is 4.33, minus b1, which we just calculated, 1.45, then multiplied by the mean of x, 2.5. So that's going to be 4.33 minus 3.625, going to be equal to 0.708. So b0 equals 0.708. And now we can fill in the regression equation. The found value of y is b0, 0.7, plus b1, 1.45, multiplied by the found value of x of this individual plus the error. So what you can see here is that if you have calculated b1, that you already know the slope of the regression line, and you can already see whether how steep it's going to be, whether it's going to be ascending or descending. But the thing that we don't know is where we are going to be placing the regression line. You are going to need b0 for that, which is the constant, the y-intercept, so to say. And b0 indicates where the regression line starts on the y-axis at a value of x equals 0. And we're going to need both values. So based on only the slope, you know how steep the regression line will be, but you just don't know where it will start. So let's fill in the regression equation using an example. So at a value of x equals 2, we get a predicted value of y of b0, 0.7, plus b1, 1.45, times the value of x, which is 2. So the predicted value of y in that case is going to be 3.6. So let's put that aside. And then we go back to the table we made at the beginning of this video. And in that table, we can also now enter the predicted values of y. So at a value of x equals 2, the predicted value of y is equal to 3.6. So we can simply enter that value. And that is true for both x's with a 2 value, of course. And if x increases by one value, then you will see that the predicted value of y increases by the value of b1. AKA, when x increases by 1, the predicted value of y increases by 1.45 because that is the slope, and that is how slopes work. And so in this way, we can continue to enter all of the predicted values of y like this. And now I also want to include the error. The error is actually the difference between the found value of y and the predicted value of y, aka the difference between the outcome and the model. And we can calculate the error very easily by subtracting the predicted values of y from the found values of y. So with a found value of y of 2 and a predicted value of y of 2.15, the error will be equal to negative 0.15. And then we can also continue to fill in the rest of the errors.